Hi everybody. As you see, I have something kind of interesting going on, a motor. The L293 chip is powering it with a special, well, we'll get into it. Anyway, let's switch to the main thing here, the lab. Okay. This is a Mega 2560 R3 and a transistor, which is the Arduino. And we got I'm using a different breadboard because it's more compatible with the circuit that I'm using, because not everything hooks up right if I didn't. So that's why I did that. Okay. Now, I can't use Arduino to power this up. Why? I'll tell you why, my friends. It will be Frankenstein City all over. Sparks could be flying, electrical, and all that stuff. This is just a DC motor, not an AC, but if I AC, I definitely see sparks and things flying. The laptop would be fried. The Arduino would be fried. It wouldn't be a good picture, and I wouldn't be a happy camper. So I'm being powered by this power supply here, the green light thing. And I'm powering it right into my light stick there. Anyway, here I can potentially power 2 motors with this. This is cool. I'm only powering one though. You have 3.3 with this thing that comes off, and you can switch it off to 5 volts. If you put it in the middle, it's off. And that's the same for the other side here. When you plug it into your breadboard, you want to make sure that it goes in the negative posts on each side here, so it plugs in equally. And that's why I had to use a newer breadboard, the one that they supplied, because I just figured it would work better, and I think I'm right. Okay, let's scrolling down. It's really kind of cool. It has its specs on here, what it's able to do. And it goes into what I was telling you about switching voltages. Because I am able to do 3.3 and 5 volts on the Arduino, but there's a feedback produced by the motor that could damage the Arduino or even the laptop, and an AC motor would definitely do it. This one is rated for, let's see here, 6.5 to 9 volts, output voltage is 3.3 to 5 volts. Maximum output current is 700 milliamps. Now, just scrolling down, because it's what I've already kind of told you. Here's a chip L293, and you see that on the breadboard too. Not as many wires this time. It's pretty cut, dry, and simple. But with that chip, one side I could power one motor, and on the other side I could power another motor. So that's kind of cool. But like everything, there's limitations. Here's the limitations. I can only do a motor from 4.5 volts to 36 volts. Otherwise, I fry the chip. I need something that can handle a higher capacity if you want an AC motor or something like that. And I know they are out there because industry uses them. You just got to know where to look. Okay. They're built with clamped diodes for inductive transient suppression. That's what I was talking about. That's protecting that circuit. The transients, the diodes in there, because that's protecting the feedback from the motor that I warned you about that can fry your Arduino or the laptop. So that solves that solution. This goes in 2 directions, so it's bi-direction, this motor. So it will spin in both directions. It has a maximum speed of 255. When you enter 128, it goes into half speed, and 0, it comes to stop. I'm having a repetitive program here, so it just keeps on going into loop and keeps on going. But here's a pinout diagram. These M's are the motors. These are the corresponding waveforms for each side. It's on this side because I'm going both directions indicated by these arrows. And if it was just going one direction, I'd probably hook it up to one section here, one diode, or one diode here. These are your diodes. Then you have your grounds, ground here, 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 here. And you have your voltage coming in here and here. 3 wires are connected to the Arduino, 2 wires are connected to the motor, and 1 wire connected to a battery. Now, it says pin 16 must be supplied with current with L293 can work properly. That's that black chip that we just looked at the diagram there. And these are where everything corresponds. If you're hooking up one motor on this side, you hook up another motor on that side. But we're only doing one motor, so we're just doing this side for the L293D. Okay. Now, for what I was talking about going in one direction, now you could do it this way too. You could hook up the 2 Arduino digital Arduino pins. I'll put one pin is high and the other pin is low, and the motor spins in one direction. But you reverse the outputs to low to high, and the motor will spin in the other direction. And you can do that with any kind of motor, pretty much. I think. I hope I'm right about that. But with this case, it's set up so that you can go bidirectional, because on this side it allows me to do that. And then I have to scroll forever on this page till I get to the next page. And here's a wiring schema. You got your COM line here, here, and here for output 2, control enable 1, output 1, control enable 1. So that's for the motor here. Same for the other side of the L293D chip. Your ground, your 5 volts, and then your 2 leads going up to the motor. Again, M for DC motor. Yeah, this could not handle AC motor, my friends, I guarantee you. It will go kabloom, and I'll have smoke, and it just won't be a pretty picture. Here it says here, you should never connect a motor directly to the Arduino, because when you switch a motor off, you get an electrical feedback. With a small motor, this will damage your Arduino, and with a large motor, you can watch an interesting flame and sparks effect. So too bad it's not the 4th of July, but even the 4th of July, I don't think we want to see it. And this is your serial port where you can see everything going on. And I'll show you all that. You open the program, Lesson 29 DC Motors, you upload it, and then the entertainment begins. The program will turn all the power switches. The motor will slightly rotate clockwise and anti-clockwise for 5 times. Then it will continue to dramatically rotate clockwise. After a short pause, it will dramatically rotate anti-clockwise. Then the controller board will send the PWM, pulse wave modulation signal, to drive the motor. The motor will slowly reduce its maximum RPM, revolutions per minute, to the minimum, and increase to the maximum again. Finally, it comes to a stop for 10 seconds until the next cycle begins. So that's why it starts and stops after all that, because we're going through cycles. And here's their wiring diagram versus mine. Now we've covered all that. Now we'll go to the program here. And we'll also get that serial monitor going. Now I'll look at the code here. The 0, 255, and 128 for the speeds. For 0 stop, 128 about half speed, 255. That's written into the program. You have your for one way, and then you have down here for reverse, because it looks like a high is one way, low is reverse. It's good to read these codes, because I don't know, might be a good idea to learn something. Nah, couldn't be. Anyway, yeah, it's a good thing to learn something. Also enable a slow stop here. You know, I'm a firm believer it's a good way to learn how to do things by doing. And I'm still learning this coding thing, but I'm learning by doing. Okay, now we'll go back to that serial monitor again. Okay, here we can see everything going. One way, then reverse, fast, slow example, pulse wave modulation, full, then slow, one way, then reverse. And it just keeps on repeating it over and over again. So, kind of neat, everybody, huh? Well, everybody have a good day. Take care. I hear we're supposed to get some rain. Keep dry. And I'll talk to you next week. Bye.